Today we will write linear equations from tables and graphs in slope-intercept form y equals mx plus b. So what we did today and Friday was that you can close your laptops, you don't need them. Close your laptops, you don't need them. Oh, well, you're good. Today and Friday, I gave you equations, and you had to take those equations and you had to graph those relationships. Meaning you had to understand what the rate of change was, right? The coefficient or the number that was in front of the variable. And then you had to understand what the y-intercept was, right? The point where the line crosses the y-axis. So first, when we're trying to look at a table or graph and write the equation for it, is you're going to have to determine the rate of change. So underline that on your paper. Determine the rate of change. That's the first thing that you're going to have to do. The second thing is you're going to have to identify the y-intercept. Underline that. If you can do those two things, you can write an equation from a table or graph. Now the y-intercept, we know the y-intercept because it's the point where the line crosses the y-axis. For instance, if this is my graph right here, the y-intercept is this point where my line crosses the y-axis. Everybody's familiar with the y-intercept by now, yes? So if I was, let's say on my graph that this was the number 3, how would I write that as an ordered pair? Sophia? It would be 0, 3. Does everybody understand why? Because as far as the coordinate plane goes, if we're looking at this green dot, then did we go anywhere on the x-axis right to left? Did we go anywhere right to left? No. Therefore, the x value is 0. And the y value here is 3. So the y-intercept is the point in a table or graph where x equals 0. For instance, if we're looking at number 1, look at the table in number 1. It wants us to write the equation of the line that is represented by each table. First of all, we're going to write it in slope-intercept form. Y equals mx plus b. Where we're going to have to identify and determine the rate of change, the m, and the b, the y-intercept. Now, it just depends on you whether you like to identify the y-intercept or the rate of change first. But since we're talking about the y-intercept right now, I want to look at it since it's still fresh in our memories. Here it says that the y-intercept is the point in a table or graph where the x is 0. What's the point in this table right here, number 1? What's the point here where x is 0? What's the y-intercept? 8, right? It's this right here. Notice x is 0, y is 8. So what's our y-intercept? 8, right? So if we're writing it in y equals mx plus b form, this would be a plus or minus 8? Plus 8, right? Next, we have to find out our rate of change. Now, by now, we should all understand that the rate of change is the change in y over the change in x. Everybody agree?
Yes, sir.
So, what's the change in y here from there to there? How much is it changing by?
That's 2.
It's increasing by 2, right? Again here, increasing by 2. So, our change in y is 2. Oh, I'm sorry.
It's negative 2.
It's negative 2, right? It's like, what? Come on. I can tell people aren't paying attention because nobody corrected me. So it should have been a negative 2. Minus 2. So our change in y is minus 2.
The other one is plus.
Now the change in x, if we're looking at the change in x here, how much is x changing by?
Plus 2.
Plus 2. So we have a negative 2 over a positive 2.
And then you have to simplify.
What would negative 2 over positive 2 simplify to?
Negative 1.
Negative 1, right? Because a negative divided by
A positive.
a positive is a negative, right? So we have negative 1. That's our rate of change. So now we should understand that our m is negative 1 and our b, or the thing that represents the y-intercept, is 8. Are we ready to write the equation now?
Yes.
Yes. So let's write the equation. I'm just looking for my eraser. Now we're going to write the equation. We're just going to substitute. So it's going to be y equals, our rate of change is -1, x plus 8. So, do I need to put that -1 there?
No, you can put negative x.
Right? If you noticed in the assignment that we did from Friday, you would have seen that some of them, number 1 was like x plus 5.
X equals 1.
Because we understand if it's just an x by itself, how many x's are there? 1, right? So I did number 1 for you. Number 2 is a little bit trickier, but I want you to solve. Remember to find the rate of change and find the y-intercept for number 2. Do it with your shoulder partner.
I have to. We're already done. Hi, Nico.
The first thing that we had to do here is we had to determine the rate of change. Again, the rate of change is the change in y over the change in x. If you can't tell me that at this point when we've done rate of change for almost 3 or 4 weeks, right? Chances are you're not applying yourself and not listening in class. Because we've been doing change in y over change in x for a very long time. What's the change from here to here? Plus 2? It's 2.5, right? 2.5. And then how much is the x value changing by? Plus 1. So, our rate of change is 2.5 over 1. Or, if you want this as a fraction, I would convert this. How do I write 2.5 as a fraction? 2 1/2, right? But for me, it's easier to have a rate of change that's a fraction because it tells me something about my graph. It tells me how much is the y changing by, how much is the x changing by. So really, if I were the student, I would want to convert this to an improper fraction. And we'll go around Texas. What's 2 times 2?
4.
What's 4 plus 1? 5. And we keep the denominator, right? So our rate of change is 5 over 2. So y equals 5 over 2x plus, what's our y-intercept? The point where x equals 0 in this table? 1. So this is the y-intercept right here. Again, we talked about it earlier. The y-intercept is the point in a table or graph where x equals 0. So we know that it's 1. Let's backtrack to see what we did. First, we determined the rate of change by finding the change in y. Y was changing by 2.5, right? We wrote it down. X was changing by 1. So we had 2.5 over 1. Me personally, I converted that into an improper fraction. Because now, if I wanted to graph it, I know my graph is going up 5 over 2. Up 5 over 2. If you wanted to go up 2.5 over 1, you could, but it just makes it a little bit trickier, right? Now, we identified the y-intercept because we know it's the point where x is 0, right? So where x is 0, y was 1. That was our y-intercept. Next, we're going to look at some graphs, and we're going to write an equation based on this graph right here. Now, the first thing that I can do on the graph that's probably the easiest for me is I can identify the y-intercept. Somebody tell me, what's my y-intercept here? Positive 2. Does everybody see the y-intercept right here? Right? So if we're writing it in y equals mx plus b form, I know my b is going to be plus 2 because it's a positive 2. Then from there, sir back there, Mr. I pay attention all the time. The next thing that we're going to do is we're going to find the rate of change. Some of you guys were like, Mr. Arnsworth, how do we do that? Well, I'm going to show you 2 different ways. First of all, we have to identify 2 pretty points. What I mean by pretty points are where the line crosses perfectly. Does everybody see the y-intercept where the line crossed perfectly? And then if I'm looking, I can see there's another perfect point here. There's another perfect point here. And there's another perfect point here. Really, you only need 2 points. You could pick any 2 perfect points. Go over there. Thank you. Any 2 perfect points. Now, you can put these into a table if you want. So what would the coordinates be for this first point right here?
1, 0,
Um,
0, 1.
we said for the y-intercept, x is 0. So this one would be 0. And then what's the y value?
2.
2. 0, 2. And then let's look at this point right here. What are the coordinates for that point? 1, comma 0. So what we can do is we can make a table out of this. An x and y. And now that we have an x and y table, can we find the change in y over the change in x? How much did the y change by?
2.
From 2 to 0?
-2.
Minus 2. How much did the x change by? Plus 1, right? So our change in y is a -2. Our change in x is 1. So what's our rate of change here?
Y equals
You're close. What?
2.
-2. So it's y equals -2x plus 2. Now I'm going to show you on the graph the easy way to do this. After you identify 2 pretty points, we figure out what the change in y is between those 2 points. So from here to here, how much did the y change by?
2. -2.
-2, because it went down 2. And then how much did my y change by? No, from here to here, how much did my y change by? Okay, hold on, because some students were confused. So we found the change in y here was -2 because it was going down. And then now I'm going to do in green. What's the change from here to here? +1. Same thing, right? So using the graph, look how we found the rate of change. I'm going to switch colors and I'm going to go yellow now so that you can see what I'm talking about. So we found the change in y. Y here was changing by 2 or -2 because it was going down. So it was -2. And then the x here was changing by +1. Hey, go. Thank you. All right. We're going to continue this tomorrow in class for about 15 minutes, and then we're going to have a quiz. Those papers with the graphs, these go in your notebook. Put them in your notebooks.